Welcome to this presentation on a Java program that calculates the monthly electricity bill for a consumer. In this program, we'll see how to apply conditional logic and basic arithmetic to compute the bill based on the number of units consumed. This is a real-world application of programming where we combine user input, decision-making statements, and formatted output to create a simple and effective billing system. Let's begin our journey into electricity bill calculation using Java. In this problem, we are required to calculate the monthly electricity bill of a consumer. The bill amount is based on the number of units consumed, which is calculated as the difference between the present meter reading and the previous meter reading. The tariff structure is as follows. For the first 100 units, the charge is 1 rupee and 25 paise per unit. For the next 100 units, that is from 101 to 200, the charge increases to 1 rupee and 50 paise per unit. And for units beyond 200, the rate is 1 rupee and 80 paise per unit. The user must input the name of the consumer, their previous and present meter readings, and the output should display the consumer's name, units consumed, and the total amount to be paid. We will implement this logic in Java using a function named calInto to calculate the amount based on units, and display the results from the main method. Before we begin writing the program, let us first understand the input requirements for calculating the electricity bill. We need three main inputs from the user. Consumer number. This will be an integer input that stores the consumer number. It helps in personalizing the bill output. Consumer name. This will be a string input that stores the name of the consumer. It helps in personalizing the bill output. Previous meter reading. This is an integer value that indicates the meter reading at the beginning of the billing period. Present meter reading, another integer value that shows the meter reading at the end of the billing period. Using these inputs, we can compute the units consumed by subtracting the previous reading from the present reading. This unit value will then be used to calculate the total bill amount based on the tariff slabs provided. These inputs form the foundation of our program logic and allow us to implement accurate billing for any consumer. Let us now understand the step-by-step logic of the program through this algorithm. Step 1. Start the program. Step 2. Accept the name of the consumer, the previous meter reading, and the present meter reading. Step 3. Calculate the units consumed by subtracting the previous reading from the present reading. Step 4. Parse the units consumed as an argument to a function named calInto. Step 5. Inside the cal function, use conditional statements to determine the bill amount based on the number of units. If units are less than or equal to 100, multiply by 1 rupee and 25 paise. If units are between 101 and 200, the first 100 are charged at 1 rupee and 25 paise and the remaining at 1 rupee and 50 paise. If units are above 200, the first 100 units are charged at 1 rupee and 25 paise, the next 100 at 1 rupee and 50 paise, and the rest at 1 rupee and 80 paise. Step 6. Return the calculated amount to the main method. Step 7. Display the consumer number, consumer's name, the units consumed, and the total amount in the required format. Step 8. End the program. This algorithm ensures a clear and systematic approach to solving the billing problem with proper use of function, input-output handling, and conditional logic. In this slide, we focus on the call method, which is heart of the electricity bill calculation program. The method is defined as public static double calInto, where U stands for the units consumed. This method calculates the bill amount based on the number of units using a tiered tariff system. Here's how it works. First, we check if the units consumed are less than or equal to 100. If so, the consumer is charged 1 rupee and 25 paise per unit, and the method returns 1.25 times U. If the units are between 101 and 200, we split the calculation. The first 100 units are charged at 1 rupee and 25 paise, and the remaining units are charged at 1 rupee and 50 paise. So we return 100 times 1.25 plus U minus 100 times 1.50. If the units are more than 200, we handle it in 3 parts. First 100 units at 1 rupee and 25 paise. Next 100 units at 1 rupee and 50 paise. Remaining units at 1 rupee and 80 paise. We calculate the total accordingly and return the final amount. By structuring the method in this way, we make sure the billing is done accurately according to the slab-wise pricing. This function is later called from the main method to calculate the amount payable. In this slide, we'll begin writing the main method of our electricity bill calculator program. First, we create a scanner object to accept input from the user. This will help us collect all the necessary details for bill calculation. We start by prompting the user to enter the consumer number. This is read and stored in the integer variable kno. It uniquely identifies each consumer. Next, we ask for the consumer name, which is a string. We use next line to read the name properly after using next int for the consumer number. This step ensures that any leftover new line character doesn't cause an input error. Then, we take the previous reading and the present reading from the user. These are stored in integer variables prev and pre, respectively. These two values are important because the number of units consumed will be calculated by subtracting the previous reading from the present reading. With these inputs, we are ready to proceed to the next part of the main method, where we perform the calculation and display the results. Let's move to the next slide for that. This slide shows the final part of our main method, where we process the input and generate the output for the electricity bill. First, we calculate the number of units consumed by subtracting the previous month's meter reading from the current one. For example, if the current reading is 2500 and the previous reading is 2300, the units consumed would be 200. Next, we call the call method and pass the units value to it. This method returns the total bill amount based on the slab-wise rate structure. After calculating the amount, we print a formatted output that displays the consumer number, name, units consumed, and the amount to be paid. The tabular display ensures clarity and easy readability for the user. Finally, we close the scanner object to prevent any resource leakage and to follow good programming practices. With this, the program execution is complete. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. Welcome to slide, the variable description table, commonly known as the VDT. This table is essential for understanding the different variables used in our Java program to calculate the electricity bill of a consumer. Let's go through each variable one by one. The first variable is kno, which is of type int. It stores the consumer number, a unique identifier assigned to each customer. Next is name, of type string. This variable stores the consumer's name as entered by the user. The prev variable, also of type int, represents the previous meter reading, that is, the last recorded electricity meter value. Then we have pre, another integer, which holds the present meter reading, the current value on the consumer's meter. The difference between the present and previous readings is stored in units, again an integer. This tells us how many units of electricity were consumed during the billing period. We then calculate the amount, a double variable. This stores the final bill amount after applying the tariff rates as per the number of units consumed. Finally, we use SC, a scanner object. It is responsible for accepting user inputs like name, consumer number, and meter readings. Understanding this table ensures that each variable's purpose and data type are clear, making the code easier to comprehend and debug. Now that we know the building blocks, let's proceed to see the output of the program. Let us now observe the sample output of our electricity bill program. When the program begins execution, it first prompts the user to enter the consumer number. In this example, the user inputs 101. Next, the program asks for the consumer name. The user enters Ravi. Then it requests the previous meter reading, which is entered as 2300, and the present meter reading, entered as 2500. The program calculates the units consumed by subtracting the previous reading from the present reading, resulting in 200 units. Based on the given tariff rates, the total amount is calculated using the call method. For 200 units, the amount comes out to be 1,200 rupees. Finally, the program displays the details in a clear tabular format, including the consumer number, name, units consumed, and amount to be paid. This output confirms that the logic, calculations, and display format are all working as expected. In this program, we first read inputs from the user, including consumer number, name, and meter readings. Then, we calculate the number of units consumed by subtracting the previous reading from the present reading. We apply slab-wise billing rates using simple conditional logic, depending on how many units were consumed. Finally, we display the bill details, including consumer number, name, units consumed, and the amount payable, using formatted output with tabs for better readability. This program uses a modular approach by defining a separate method called calInto to calculate the bill amount based on units consumed. The if-else logic used in the method clearly handles different rate slabs, making the billing process easy to follow and understand. It's a great practical example of applying conditional statements and handling user input in Java. The output is clean and professional looking, thanks to the use of tab spacing for formatting, which enhances clarity and presentation. That brings us to the end of our session. Thank you for watching this lesson on the electricity bill program using user-defined method in Java. We've successfully built a Java program that checks for twin primes using functions and logical checks. All the important components, the question, algorithm, Java program, variable table, and output, are available in the description box below. If you enjoyed this tutorial, make sure to like the video, share it with your classmates, and subscribe for more helpful programming lessons. Until next time, happy learning.